This book that I hold in my hand, you see right there, is the most important book ever published in geology. Yeah, I will say it again. It's the most important, not one of the most, but the most important book ever published in geology. It's called Beyond Plate Tectonics, Unsettling Settled Science by Dr. James Maxlow, a good friend of mine. And he sent me the book. The reason I'm doing this, and it's going to be a long video, is because this is not available here in the United States. It is available in other countries. You can check it out, look it up. I'll put links down below to the ones, the places you may be able to get it. I do have an electronic copy, but I'm not allowed to give that out. And that's how I got the graphics that you're going to see here today. But I'm going to read the back of this book, which really explains what's going on. And let's go forward. Beyond Plate Tectonics. Science is never settled. New revolutionary ideas have always overturned the settled sciences of the past. In this far-reaching book, the author looks beyond plate tectonics in order to detail the next Earth science revolution. Drawing upon his work from 4 decades as a professional geologist and researcher, the author reveals the weakness of conventional plate tectonic theory. This research utilizes an extensive range of global observation data in order to reverse engineer geology back in time. Reverse engineering seafloor and crustal geology enables past plate assemblages and configurations of the ancient continents to be accurately constrained using geology rather than geophysics. From this, a series of spherical geological models of the Earth are presented, showing the precise location and configurations of the ancient continents, ranging back to the time to the early Archean. These plate assemblages represent the first time that models of the ancient Earth have been geologically constrained back to the early Archean. As extensive range of additional global observational data are then displayed on the spherical models in order to quantify the location of the ancient poles and equator, climate zones, biogenic distributions, exposed lands and seas, as well as global distributions of hydrocarbon base and metallic resources. The research outcomes presented in this book are applicable to all disciplines of the earth science and will appeal to a broad range of professional expertise, in particular those with a grounding in the earth sciences. It is a must-read for undergraduates and professionals alike. This book doesn't have a ton of new information that you may not already know if you've been a student of Dr. Maxlow's, but this is the first time it's in a comprehensive form that could be taught anywhere around the globe in geology class and earth sciences class, and it goes way beyond geology. And of course, we people in expansion tectonics know that. I want you to notice that you do not see expansion tectonics written anywhere on the back. Well, it may be further in his little description, but in that description there was no mention of growing, expanding, mass increase of the earth, nothing. And of course, if you look right there, you're going to see that beyond plate tectonics, unsettling settled science, there is no mention. So the idea is, and I agree with it, is, expansion tectonics isn't what he's talking about. He's talking about geology the way we're supposed to be looking at geology, and tectonics the way we're supposed to be looking at it, because the data points to this. The data points to an expansion by the earth. The data points to mass increase. So it's just, let's just talk about it, because this is the new textbook for plate tectonics. That's it. So let's go forward. And I've picked out, and I decided it because you guys can't, many people here in the United States, they can't get the book, and many of you are not going to be able to get the book. I'm going to look through the table of contents. Chapter 1 is controversial ideas, conventional wisdom. Of course, he's talking about the idea of the expansion versus regular plate tectonics. Chapter 2, the new discoveries, geological timescale, magnetic seafloor mapping. He's telling you in this book what were the things that triggered the ability for him to do all his research and write this new book in the new discoveries. Geological map of the world, measuring the seafloor surface areas, measuring potential ancient Earth radii. That's really important. You notice again, he's not talking about expansion. You don't see that word there because it's not necessary. This is now geology. This book is now geology. It should be taught everywhere. Will it? That's a different story. Modeling seafloor crust, assumptions, model construction, observations. So that's modeling. We'll take a look at some of these. We're not take a look at everything. Everything that I'm listing here, we're not going to be taking a look at. I just wanted to make sure, since not very many people can get this, and probably most of you will not have this for a while, that I would make this extensive video on this. So chapter 5, modern oceans and seas. He goes through literally and looks at all the oceans according to this plate tectonic model, or as we know, we call it expansion tectonics. So what you see isn't just one view of it, and what you see are not only reconstructions and looking at the seas like the Caribbean Sea or the Indian Sea. He has views of those. We'll see that. You would see all the little models as well, from the smaller Earth radii to the bigger Earth radii. Pre-Jurassic Earth radii. He's talking about something because it's at the time where there was a big crustal breakup because there's a big expansion period that all of a sudden started going much faster. Modeling continental crusts. That's really interesting. How that actually fits the new tectonics. He talks extensively about that. Chapter 8, ancient supercontinents. That is, we have supercontinents, and we know all here heard of Pangea, but when you look at the new plate tectonics paradigm, which has been called expansion tectonics in comparison to plate tectonics, there are very interesting and much better way to find the supercontinents, have their names, and really describe geologically what's going on and why they are that way. Very, very precise. The model is so much better. I would say it's 1,000 times, and I'm not exaggerating, 1,000 times at minimal better than the today's plate tectonics. Oops, did I not talk about everything in that? I don't think I did. Chapter 9, modern continents. So they're looking at those continents and how people are, of course, we know the modern continents, we live on them, and even looking at the future. The modeling summary in chapter 10. Then we get part 2, empirical global data modeling. The chapter 11 is probably going to be the most interesting to a lot of people because there's proposed causal mechanisms. Why is the Earth expanding and why does it gain mass? I mean, it's one thing you can think of the nuclear, you have stars blowing up, getting bigger. There's all kinds of nuclear reactions going on in the center. That's what at least is thought to be happening. Well, that could be happening in Earth. No, we are looking at the proposed mechanism for the expansion, and this includes mass increase. That means, and it's not from accretion, things falling on the Earth, but he talks about all those things, and as a geologist, what he chooses, and that's an interesting part, which one he chooses as what he thinks is most likely. Paleomagnetics, the magnetism tells us a lot about how the Earth grew, increasing the radius, how that happened, looking at the paleomagnetic poles. That was one of the things that got Dr. James Maxwell, the reason became expansion technologist and wrote the most important book in geology ever. How did he get there? Because when he plotted the poles on in Earth with an expanding radius, he could not deny that it pointed so precisely to an expanding Earth that at that point, he said he could not go back. It was a done deal for him. So paleomagnetics, we have chapter 13, space geodetics. You can take a look at that. There's plate continental motion. We'll take a little bit about, have some diagrams. I'm going to try to touch on some of the more interesting diagrams from the book. Some of these, many of them, some of the people who really studied Maxwell for many years are going to recognize. Some are new, and some are just fantastic. In this book, I opened it up and I was just blows my mind. This book is just incredible. Did I not talk about everything else again? Yeah, geological implications, changing Earth's surface curvatures. That's one of the things he looks at. The crustal mechanisms, crustal formations, those kinds of things. You're looking at a very different dynamic when you're talking about a fixed radius versus, in this case, the new paradigm, which is an expanding radius. That in itself has a lot of physical characteristics. He talks about that. Paleogeographic evidence, ancient shorelines, ancient continental sedimentary basins, rise and falls of sea levels. Again, this stuff just fits so well. You cannot go back. This is fact. This is fact. This is fact. I can't tell you enough about that. I will. You're not gonna. This is one that I will say, this is a truth. Okay, let's keep going. And the chapter 16 is paleoclimatic evidence, present day and ancient climatic zones, distributions of ancient polar regions again, early, and it's broken down. Again, you can see this is very geological, meaning it's a geology book for sure, and it's full of earth sciences. It's full of earth sciences, and it will touch many disciplines. Chapter 17, extinction evidence. There are mass extinctions, and he talks about that and plots that in this new paradigm. So you can see there's quite a lot of what goes in this book. And here are the ending chapters. Here you have paleobiographic evidence, biogeographic data modeling, Precambrian life. So you start looking at the life, how it's affected, what it's like, and when now related to this new paradigm of expansion tectonics. You have metallogenic evidence. This is very about geology. I'm not a geologist, so I'm not going to tell you that I understand this or care to understand it. All I can tell you is that I am sure from a geologist's point of view, this is very good and important information. Fossil fuel evidence. Of course, he's talking about fossil fuel. There's some disagreements that I have. It's abiotic in my opinion. It doesn't really come from fossils. We think it's being manufactured inside the earth the same way as oil's being manufactured inside the earth. This process of mass increase and mass of the earth and expansion is also producing elements. We have that happening in the middle of stars. Why don't we have this in a furnace in the middle of the earth? So that one, again, I said, doesn't change this book. This book is absolutely amazing. He has opened the door to tens of thousands, maybe hundreds of thousands of master's and doctoral degrees in areas that we just don't exist right now. And it's not only him. He's standing on the shoulders of many people, yes, but he's first to put it in a book form that's real, teachable, and plunk that down on the desk and teach anywhere. Continental example, Australian crustal development. He talks about something more specific because he lives in Australia and he's been on the ground, obviously, and wandered around that continent. And I'm sure that's got amazing information there. I have gone through it. I don't remember all the details of geological rock record, primitive atmosphere and hydrosphere, Archean crust mantle, Proterozoic Earth, Paleozoic Earth. So these are all terminology, again, for people doing geology, ancient geology, and paleo work, I guess you want to call it. Then you have chapter 23, a paradigm shift in thinking. That is the conclusion, and obviously that's what this book is putting forth, and his work for many decades have been putting this forth. Glossary of terms. There's actually, oh my goodness, there's 20 to 30 pages of terminology. So if you're not a geologist, he really tries to make you understand this, because he realizes, and as I do, and as many people do who know expansion tectonics and subscribe to that theory, we know that this is going to involve way more than just geology. It's going to involve paleontology, and the paleo part's going to be just magnified. Paleogravity, there'll be people writing papers, maybe even have conferences in the future about paleogravity and the evidence for that. So it's just pretty amazing. And then he has some actual calculations that have to do the kinematics, the radius, circumference, surface area. I'm going to show you some of those, and the formulas. So he has actual mathematical formulas for helping out with what's happening with the size of the Earth, etc., etc. So that's really I wanted to make sure you all saw the entire table of contents, because again, you're not going to get this book most likely. It's not easy to get a hold of, and he's working on it. Believe me, he is working on it. That was my first question to him before he sent me this electronic copy, which was a lot easier because I had photographed all this stuff from this book, from this actual book, and I said, no, this is not working. It's not going to be good for you guys. So I actually got he gave me the PDF form of it, and I will show you now the interior of the book. And I am not going to show you everything. I'm not going to go through each chapter like I just did. I'm just going to pick out. They're somewhat random, somewhat, again, in my time constraints. If I would prepare a month on this, then of course it would be much more organized. But at least I'm going to be able to click through and give you a good idea what is there. So, not too much text, mostly diagrams. So let's go forward. This book, of course, is dedicated to those people whose shoulders he stands on. One of those people is Klaus Vogel from, I believe he's from Germany. And he is a picture. There's James on the left, Vogel in the middle, and Koziar on the right. They are all there. That was in 2011. And he met and they were be able to work together in the Earth expansion evidence that was in the 37th interdisciplinary workshop, and that was a challenge for geology and geophysics and astronomy held at Majorana Foundation in Sicily. So James is extremely grateful, and to me, he shows over and over his really extreme reverence for and Ernest Klaus Vogel, who passed away in 2015. And so you're always going to see James not take credit for a lot of what he's doing, but believe me, he's the first geologist to take all these ideas and put them into the first comprehensive tome that is going to set the precedence for the next couple hundred years, in my opinion, in the earth sciences. So let's go forward again. Part 1 is Introduction to Historical Aspects and Geological Modeling. I'd like to read you some of the quotes there because these are some that James picked out. Science does not, in the proper sense, discover new facts or regularities in nature, but rather offers some new ways of seeing and understanding the physical world. And that's exactly what this book is about. The facts are we may see new facts, but it's the way we look at these facts that are changing, and that's what expansion tectonics is. And this is the part 1. Chapter 1, he talks about controversial ideas. I'll read this first part to you. Scientists still do not appear to understand sufficiently that all Earth scientists must contribute evidence toward unveiling the state of our planet in earlier times, and that the truth of the matter can only be reached by combining all this evidence. It is only by combining the information furnished by all the Earth sciences that we can hope to determine truth here. That is to say, to find the picture that sets out all the known facts in the best arrangement, and that therefore has the highest degree of probability. Further, we have to be prepared always for the possibility that each new discovery, no matter what science furnishes it, may modify the conclusions we draw. And he's talking about geologists have to look at, and paleontologists have to look at a big set of data, not just the rocks. You have to look at the life forms. You have to look at the flora, the fauna, the geology, the magnetic parts that you see, the way the crusts are observed, all those things. It's huge. This book again opens up in this discipline. Again, it's not the first time, but it's all put in this one book. Here is one of the things that James was telling me over and over in the last 10 years, I think, since I've known him. And I really understand what he's saying now. And he is in extreme pays homage to those people and has a lot of admiration for those people who have built models, because this was before 3D models. 3D graphics were easily done, like Neil Adams did in the early 2000s. Of course, if you've not seen Neil Adams videos, you must go just look up Neil Adams Expanding Earth or Growing Earth, and you'll see this. These models were the way that these geologists were being able to look at what was happening on expanding Earth. It's really hard. It is really hard to not only visualize without a real thing in front of you. A sphere is a hard thing to deal with. You can flatten things out, but it isn't the same, because this is growing in all three dimensions. So when you're doing this, and this is a model made by James Maxlow, a gift from him to me that he promised, and it took him 9 hours to make this one, and it's just copying one that he's done before. And he made dozens of these models, and this took years and years. And to do it on the computer we're just starting out. Stephen Hurl's trying to do that. If you're interested, look up Stephen Hurl, Dinosaurs and the Expanding Earth. Get in on the project, help him out. But it was the models that were really important. And these are reproductions of Hildenberg's small Earth models, which was even before Vogel. Vogel made his models as well. There are other pictures, but again, this is a big book. I don't have time. I literally have 40 slides, and I'm on 13. So, oh my gosh, I just made people leave. But no, stay around, folks. This is really great stuff. Or pause it and come right back. Great stuff here. There are some more models. These are Vogel's models, like I was saying. You can see 1983 Terrella's models. Terrella, it would be a small diminutive, so those are smaller. You can see here the last one right there. This last one, you can see actually there's a globe there that's transparent, and the Earth inside. That's a dramatic, that itself is just a dramatic thing. And you think those are easy to make? They aren't. Try making a globe sometime. So anyways, he is a great admirer of the actual model building, because he's a model builder himself, and it is not easy. And they're the one, these models that James Maxlow, which you're going to see pictures of throughout the entire book, you can see there's South America. See all the different colorings? Well, that has to do with the types of rock it is, the geological state of it. So he not only goes back to where the Neil Adams videos, he goes beyond that to an even smaller Earth. And that's when you have to understand that even some of the continents today were smaller than they are today. So it's quite amazing. And the only way he did that was with models, and they are absolutely beautiful. Okay, here are the choices you have in tectonics. We're going to call it plate tectonics, but just tectonics. Crust, Earth, constant Earth radius, plate tectonic Earth. In this theory, excess crust is intruded along, that is, it grows in the middle of the oceans, and it goes and it dives underneath the continents to be subductive. That's the current state of what people say is, if you go to a college, university, and you get your degree in geology, that is written in stone, unfortunately. Partial increase of Earth radius. In this theory, some excess crust is disposed along subduction zone during a limited increase of Earth radius. Pulsating Earth radius, you can get an idea. Crust is generated and spreading, and sort of like this, and maybe that's also one. And then there's the increasing Earth radius, which is expanding Earth or expansion tectonics. For an increasing radius Earth, new volcanic lava intruded in the mid-ocean spreading centers is cumulative with time. It is not subductive. Even though there may be some small subduction zones, it is just continues to increase. So those are the things set up. Modeling the seafloor crust. This was probably the biggest evidence for expansion tectonics that came out. Very important. But in the end of the rigorous approach, the rigorous approach has paid off, for it has revealed a discrepancy which had not been apparent. It was not my method that was at fault, but my assumption that the Earth of Pangaea was the same size as the Earth today. The assembly of Pangaea is not possible on the Earth of the present radius, but on a smaller globe. These difficulties vanish. So if you don't know about what that is, those are there was a survey done in the 1960s going through and measuring the age of the ocean. They could not find any ocean older than 200 million years. Now, if you look at this in the Earth, this is giving an example. He's going to look at the North Pacific Ocean in this case. And that North Pacific Ocean, which tells you, let me go back I'm sorry about this, but I didn't show you that. I should have probably had that famous map on it. But you see these sort of lines that look like fracture lines, and they're sort of, you see there you see some more there. All of those are bands of 10 million years of the ages, whoops, don't fade out of me. It's focusing, the ages of the seafloor, and from that they can reconstruct the smaller, by taking those away, you can reconstruct the smaller Earth radius. And so here's one that I thought was really interesting. This is the North Pacific Ocean, because we know, of course, that South America fits in the Africa. Any child can see that on a globe because they're very close together. But on the Pacific, you can't, so I chose this one. It's very interesting. So if you look very closely at the bottom left of each of those, you're going to see Australia, the home continent of Dr. James Maxwell. If you look on each one of those, you can go down one by one until you see the very bottom, you see some circles. Well, right there between those circles, the one before it's all closed in, you're going to see there Australia coming together with North America. So this is really interesting, because even though you can't see it, it's not apparent, because when you look at the Pacific side, all you see is ocean, that in fact the Pacific side closes down. You can watch Australia snuggle up right next to the coast. And of course I have a video that talks about that right here. And they found that out, I think, last year in 2018. They go, oh my gosh, we're finding geologically that the west coast of Australia matches up with California and or Alaska, in that area in North America. How could that be? Well, this is exactly why. This diagram right there, the second one over from that solid one, that one will show you right there, there's North America and Australia. Now, this is another famous a graph that you've probably seen from Dr. James Maxwell, and that graph is of the expanding Earth. And you can see that it was expanding slowly. It was not ever constant. And then all of a sudden, you see a real movement and a real, more almost exponential expansion going on in the last couple 100 million years. And that's really important, because it is not a linear process. Here is really interesting, changes in Earth mass, density, and surface gravity. So now he's not only measuring the radius, but he's now looking at the density. He's looking at the surface gravity, because that's changed. And that if you see down there, it says constant Earth mass. And the idea here is the same idea that Stephen Hurl, with his book called The Dinosaur and the Expanding Earth, he also was looking at the dinosaurs and the biggest animals, and found out that gravity had to be less in the past than it is in the future. It is today, and that explains for the giganticism, because those beasts could not exist. If you put Jurassic Park here, that Jurassic Park would not exist. All those animals would die if you could get them to old age, which you couldn't, because when they're born, maybe they could survive a little while, but as they grow older, their bodies and biology were made for a less gravitation, and that allowed them to become gigantic and still pump their blood, still walk, and still be able to lumber around but we've tried to explain that with, oh, they were in water, or oh, it was different, the atmosphere. They've tried everything, but this is a great explanation for that. So that's a really great graph. Part 2, empirical global data modeling. Ultimately, world reconstructions must be congruent not only with data from the geology and geophysics, but with paleobiogeography, paleoclimatology, and paleogeography. Now, I've skipped some of chapter 11, which is the mass increase. I'm putting that at the end, so I'm not going in order. So yes, I have skipped a lot of stuff that's going to be repetitive, the oceans and showing the oceans, those kinds of things. I'm going to try to show the highlights of these parts, because some of them, because it's geology and you're going to, as a geologist, discuss every ocean, every continent. Those things are in part 1 and in very great detail for geologists, and I'm sure that they enjoy that, but we don't want to just be repetitive here. We want to I'm trying to give you the meat of the book here. This is really one that, of course, other people have already seen, and this is, oh, what did the Earth interior, how does that look compared to what was going on before the Earth was really expanding a lot? And this is where he's looking at a schematic cross-section of the Cambrian, Permian, and present day, highlighting the effects of Earth increasing its mass radius over time. Core and mantle dimensions for the Permian and Cambrian models remains speculative only, of course. I mean, the guy can't solve all these problems. This is why we need this to be taught in all the universities, so we can get answers to these things, because James can't answer it all, even though he's put it together in a tome to set the foundation for doing things like this. And he rightfully says speculative, which most people will not say, because they all either think their theory is completely right, everybody's wrong, and they go preaching. If you're a true scientist and a true engineering spirit, you're going to say these are the best things we can do. Yes, expansion tectonics looks 99% for certain, but the details, we still have a lot to work out. Truly a great to be modeled, that kind of attitude of critical thinking. Paleomagnetics, of course, that's very important to expansion tectonics and the new tectonics, we basically call it. The many geophysical and geological paradoxes that have accumulated during the past 2 or 3 decades are apparently the consequences of forcing observational data into an inadequate tectonic model. Now, this is by somebody back in 1992, so this is going on. So small Earth geology modeling studies have now reached a point where additional paleomagnetic evidence can be introduced in order to physically locate ancient magnetic poles and corresponding equators on each model. This is really important, again, because this is exactly what made Dr. James Maxlow into expansion tectonics, tectonicist. So that's really important. So looking at this now, because it's very complicated, the magnetic parts, when you look at the ground and the surface of the Earth, they're going all kinds of different directions, over here and one and the over here, and you've got to sort of put them together. It is a huge puzzle to put together. Again, dissertations there are going to be lots of them in the future over this. And here's an interesting, this is the apparent polar wandering path for North America is in red. The actual magnetic pole is in green. The apparent polar wandering path for Eurasia and the actual magnetic pole. So they're looking at these magnetic poles and they try to find out where, how they're moving. And when you look at this in the direction they're moving, and you look at this on an expanding Earth, they are shockingly good. Dr. James Maxwell told me that you can almost, put a stick right through the center of the Earth and know exactly where the North and South Pole were. They were on it, and get amazingly accurate reading of what the radius was most likely in ancient times. Space geodetics, proof of any theory comes through direct observation or direct measurements. Both paleomagnetic and space geodetic measurement techniques are now routinely used in conventional plate tectonics. studies for determining past and present day plate motions and plate assemblages on a constant radius Earth. In addition, the outcomes of these techniques are used as confirmatory evidence in support of the constant radius plate tectonic Earth model. It should be appreciated, however, that the evidence presented by both of these disciplines are derived mathematical entities and established formulae used in constrained to and must adhere to a number of applied constancy assumptions prior to their calculations. So in other words, they have baked into their calculations for looking at space geodetics, they're looking at them, and the formulas that they derive are formulas that they are using are assuming a fixed radius. So it is a chicken and egg problem that he states here in chapter 13, and he basically says no, that's because you're assuming it's that way. If you look at that same data with the new expansion tectonics or new plate tectonics, you will have a very different conclusion and different equations. And that's what he's pointing out here. And in fact, here you go. These are arrows. The bigger the arrow, the bigger the movement. And these are all the movements of the plates today. And you can see by looking at this, and that's what he's talking about, the horizontal velocities, vectors, and geodetics, movement, geo-movement. I believe that's how you can sort of break that word down. Now are again some really interesting things that I'm more mechanically inclined, I guess, and this was really fascinating. Take a look at this, because this is something you're not going to get ever in today's plate tectonics with fixed radius. Right there you can see that below at the bottom is when the Earth was smaller, and that's a smaller radius. You notice when it gets bigger, there's all kinds of things that can happen. You can have an ancient Earth surface, the curvature gets less. When you have the curvature that gets less, you notice that those little pieces, the ancient continental crust broken up into 3 pieces, not only break apart and separate, but they also get different curvatures. Their curvatures are represented. They're different than when they put them all together, which made a smooth surface. So now what you're looking at, like right here, you're starting to look at, say, okay, we have a whole different system now that we have to look at when we are looking at the plates and all the layers that we look at as geologists, because now with this type of mechanism we have to think to ourselves, what's really going on? It is much more complicated. Doesn't mean it's a bad model because it's more complicated. It just means when you have a 3D sphere growing and cracking, and man, trying to reconstruct it is not easy, but there are lots of clues. Here's something that many have seen before. I'm not even sure if this was, I think this wasn't even James Maxlow. I think it may have been Carey in his book. But this is showing that when you take a surface like this that's curved and then uncurve it, you're going to bunch it up. It's going to have compression. That's what happens. When you do that, you have a tendency to bunch up on the ends and make a sort of a valley in the middle. So you have South Africa, Australia, South America, India, all showing these crustal pieces, and what happens to them when they get broken apart and become less curved. This is the result of that. And mountains, in fact, aren't because you have stuff underneath it pushing up. It's because they're being formed because of the uncurving of a curved surface. And you can actually do that on a balloon with mud, let it sort of get semi-dry, and then blow that balloon up, and you're going to see mountains form. Whoa, that's pretty cool. This is one of my favorite from the new book. Maybe is my favorite, these type of diagrams. This is just blows your mind. No, that's not layers inside the Earth. Right there are 3 radii of Earth, way back in the Archean, and then in between that into then the modern. So the circle in the middle is the Earth way back. The one in the very center, the one that's in between the center and the outer ring, the second ring, that one is in between Earth expansion, so it's a bigger one. You can see you have the crusts, and he's showing you some geological ways that this will happen and what happens when these you have this expansion going on. You can see that on the very last one. You'll see the modern ocean at the very top. That is that it's spreading and the water's shooting out of the smokers at the bottom. Water's shooting out. Where's it coming from? Guess what? It's being manufactured inside the earth. Well, you can also see shallow seas in the center one, and the second one in the middle between the two other rings, the center ring and the outer ring. You can see the shallow seas, as Neil Adams also points out. This is absolutely fascinating. And these types of graphs, these are going to be the way geology is going to be seen. It's just fascinating. It makes exciting again. I think there's a lot of people going to go into geology just because of what this book is presenting. And what expansion tectonicists have presented, but in this way, finally, in a real geological book that can be used for teaching. Okay, paleogeographic evidence. Ultimately, world reconstructions must be congruent not only with the data from geology and geophysics, but also with paleobiographical, paleoclimatology, and paleogeography. Ancient geography, referred into the geosciences as paleogeography, is a study of the Earth's past geography, and in particular the geography of ancient land surfaces. It includes a study of distributions of configurations of ancient continental land masses, their topographical relief, etc., climate zones, etc. And I would add there too paleogravity, because if we have only one piece of evidence that I have heard of that was actually not discovered, but found by Stephen Hurll, the guy who wrote Dinosaurs in the Expanding Earth, which was ancient sand dunes were steeper on the average than today. If you have more gravity, it's going to push down those little grains of sand. It's not going to be able to stack up as high. So that's actually geographical evidence that the gravity was less. That's huge, and I think that would be an entirely new area that I don't think he put in this book. That, hey, James, I know you're going to watch this. Put that in your next edition, because I think that is going to be fascinating, because we have only found one thing. Imagine there's probably lots and lots of other things, and that will add immensely to the idea that there's actually mass increase to get rid of those people who don't believe so. Here's interesting late Jurassic shoreline. So this is this smaller Earth. I thought it was really interesting, this globe, because it's smaller. Look how big Africa is compared to the globe. Believe it or not, all the continents are still there. You notice there are shallow seas. Where is Europe? Oh my gosh, it's underwater in a shallow sea. So you can see late Jurassic shorelines highlighted as heavy blue lines, shown in relation to shallow continental seas, shaded in blue, as well as distribution of exposed lands and newly opening North Atlantic and Indian Oceans, shaded in dark blue. So that's, you can see that over there, the North Atlantic Ocean, you can see it off to the left, and the Jurassic Indian Ocean starting to open up, meaning these are much more profound, much deeper, and this is when you get the start of the plates that we now see being formed underneath our oceans today. So this is really, really cool. I like that. And here is interesting. Here's that same graph of the expansion where you have the water. That's the blue. You can see we're getting more water. More water is being manufactured and being spewed out of those black smokers. You can see the water-land relationship, mass relationship. And here you can see the extinctions. And this is really interesting because all of a sudden you have another thing you have to look at is these extinctions happen. Why did they happen? How does that fit on an expanding Earth? And again, this is new stuff, folks. I'm not sure, but maybe Dr. James Maxwell is the first one to put these together in this book form. There are these things I did not see before, or if he's talked about them, he didn't put them in a formal way. So he's trying to make this book teachable all the way to the end of everything you can imagine. And And there's even more than in this book, but it's amazing. Paleobiographic evidence. Plate tectonics reconstructions and proposed movements of continents do not correspond to known or necessary migration routes and directions of biographical boundaries. So now you have life on top of this, and how's that working? How did the dinosaurs go around? We say, oh, the dinosaurs were on this, but then they were over here. How could they do it on Pangea? They couldn't get all the way across there. How did that happen? Blah, blah, blah. Well, all those things now have to be graphed. So the people who are working with dinosaurs now have to say, okay, this dinosaur is what time? So we should be able to find this dinosaur in these places because we know that that the land masses were in certain places and the shallow seas were in other places, and therefore we have to take those into account. And here you go again. We have the geological time, millions of years to the present day, and you have now you're looking at the actual life. Now with an expanding Earth, you can find out why was there everything in the sea. It just seems like everything was in the sea. Or why was this here, this was sea and this was land, and now it's land and this is sea, or vice versa, whatever. All these things now, all these land invertebrates, dinosaurs, flowering plants, insects, all of these things, humanoids, they are now have to be looked upon in the context of expansion tectonics and expanding radius of the Earth. Again, I've never seen this before. This is fantastic. Best book in geology. Hell, what can you say? A paradigm shift in thinking. The biggest problem facing geoscience today is accepting that plate tectonics may well be better suited to an increasing radius Earth scenario. So you notice that, yeah, it is plate tectonics. It's just Dr. James Maxwell coined it expansion tectonics because he, in fact, wanted to distinguish it from today's plate tectonics. But this book now, what we called expansion tectonics, is now plate tectonics. It's a done deal. How long it take the universities to teach this, I don't know. But it's a done deal. This book will be looked upon as the biggest tectonic shift, pardon the pun, ever in geology. This, and of course, he's standing on the shoulders. But he was the first geologist to accept it and to apply everything that he knows about geology, and even looking into areas he doesn't know, because it's now forcing geologists to look at that. So one of the primary aims of this book has been to encourage all scientists to broaden their research outlooks beyond conventional continental drift-based plate tectonics thinking in order to at least look and consider what else modern global tectonic data has to offer. Since the mid-1960s, that's when they came out with those seafloor dates. This modern data has traditionally been constrained to a constant Earth radius. Continental drift-based theory. Let me do that. This modern data has traditionally been constrained to a constant Earth radius, continental drift-based theory. Yet nobody has bothered to test this data to see if the mechanism for plate tectonics is indeed better suited to an increasing radius Earth concept. Again, I love the way he's framing it. He's not saying that, oh, there's expansion tectonics and there's plate tectonics. No, there's plate tectonics. And the Earth's radius is increasing and mass is increasing. That's now we have to take that into account. If you don't, you're wrong. Proposed causal mechanisms. So that was the book in general, but I want to get to the last thing. And this is the thing that plate tectonicists, modern geology and plate tectonics, says that the reason they do not go for the increasing radius idea that the Earth's radius is increasing is most likely because they don't see that from physicists. They don't see it from any mechanism for that in physics. They don't see anything from biology or paleontology that they're saying that and screaming from that, even though that is starting to happen, like Stephen Hurl's book with dinosaurs show very clearly how they can't survive in the gravitational force for today. So those things are there, but they always say, well, you don't have a mechanism for this. There's no physics mechanism. Well, let's just take a read here. It may It may be fundamentally wrong to attempt to extrapolate the laws of physics as we know them today to times of the order of the age of the Earth and of the universe. So what he's saying is that maybe it's we can't extrapolate the laws of physics as we know them because maybe things were different in the past. Interesting. I'm not sure. I'm going to read that again. It may be fundamentally wrong to attempt to extrapolate the laws of physics as we know them today in order to them today to times of the order of the age of the Earth and of the universe. Okay, so I think what he's saying is that we can't just say the physics that we know is sufficient. We may have to actually change our physics. And that's what we need to do. We have to look for how mass increase could happen at a subatomic level. So it says here, irrespective of empirical evidence, the theory of Earth expansion was rejected during the mid-20th century based mainly on the lack of suitable and convincing mechanism to explain the necessary increase in Earth radius over time. This rejection was further quantified by conclusions of paleomagnetics based on measurements of ancient Earth radius from paleomagnetic pole data. The paleomagnetic pole data was used earlier for explaining a possible mechanism for what is causing the continents to move in the continental drift theory. So he's talking about what is the mechanism and where can we look for that mechanism. He says the answer may be at the poles. So we'll take a look at some of the things he lists in this important chapter, in chapter 11. If the Earth is undergoing an increase in radius, as geological studies presented here strongly indicate, there must be a mechanism whereby the Earth increases in mass with increasing time. I believe James took this from another person who did this. I know the person actually personally, and I can't remember their name off my top of my head now. Previously proposed mechanisms for mass increase are not considered feasible for various reasons, primarily because of the lack of current principles of known physics or esoteric theories lacking experimental verification. It is conservatively estimated that the sun ejects sufficient quantities of matter in the form of electrons and protons to account for the increase of mass of Earth over the geological periods of time being discussed here. What that means is, of course, atoms are blown apart and shoved, the pieces are thrown out by suns, not only our sun, but suns around the world. So people are saying only from the Earth, but I would make a correction there and say the rest of the universe is doing the same thing. And yes, the sun has the major portion of it closest to us, but mass increase also occurs from not just the sun, but from all the bodies around us in the universe. Individual atoms and ions are generally of sufficient size of the order of nanometer that penetration of such particles into matter to any significant depth is generally highly unlikely. What he's saying is that the chances of like a nucleus to go all the way through the Earth or something is highly unlikely, and many of our models agree with that. Since the movement of both electrons and protons, as for electrically charged particles, is dependent on the presence of magnetic fields, celestial bodies not having magnetic fields like that of the Earth, such as rocky planets and the Moon, most likely do not exhibit similar mass increases via this mechanism. Yes, what it's saying is that because we have a magnetic field, that magnetic field captures these particles and brings them into the Earth, and the Moon and other places that don't have such big magnetic fields, that's not going to happen. So, and if you look at other, in fact, like Jupiter, which has a huge magnetic field, there's a speculation that Jupiter was much smaller like the Earth, and eventually the breaking of the crust then, and instead of just water and other things coming out, other things started coming out of it, and you get lots of gases, and that's why you have these gas planets, that eventually the Earth will turn into a gaseous planet. That's not in this book. That was just David D. Hilster ad-libbing. Exactly where within the Earth electrons and protons combine to form new atomic structures is open to conjecture. That's true. The D layer is a prime candidate because seismic detectable activity appears to be occurring at that level, although it may be happening elsewhere, such as within the mantle or even perhaps upon the core itself. It has ever even been suggested that the existence of a molten mantle may be necessary for mass gain to occur. So there's what James is saying is we don't know really where. The D level seems to be where they would guess right now, but that could be completely wrong. Although poorly understood and desperately begging more theoretical studies, the mechanism appears to be a viable solution to the problem of the apparent mass increase to Earth over geological time. Meaning that mass is the proton, or the nucleus of an atom. That's almost all of its mass. The electron is very little. And that protons are known to be blown apart, atoms blown apart, and that the sun shoots those around. That's what comes along. If a proton hits you, this is why when you get these storms from the sun, you're getting these protons shot at you. They're not like electrons. Electrons aren't going to hurt you very much. It's the protons. And those things will do absolute damage, and that's why we have to shield our astronauts and all from that. And that's a likely candidate for mass increase. My father's with his our particle model says the same thing. Mass has to increase. If you're increasing it at the atomic level or subatomic level, it's going to be the nucleus. And of course, we're going to I'm going to show you the last part of this. My goodness, we're coming up on an hour, so I will be under an hour. So that was my goal, but I knew that was going to be long. I appreciate if you've gotten this far. It's definitely worth it to see the most important geological book ever written. And here you can see some of his equations that he has put together: radius, circumference, surface area, volume, mass, density, gravity. So he's put together some equations. This is not all of them. It's just to show you that he has equations, what some of the things he's calculating. So for instance, radius is increasing 22 millimeters a year. More or less, you're going to, in your lifetime, it's going to increase about the length of how tall you are. 140 millimeters a year is the circumference. The surface area is 3.5 kilometers squared per year. That's pretty amazing. And the volume is 11,000 kilometers cubed per year. That's also amazing if you think about it. The mass is 60 times 10 to the 12 tons per year. That is incredible. Density, he's saying, stays pretty much the same. Surface gravity, it changes per year and is getting heavier and heavier. You can see it's going minus, so we are having heavier, so that a million years from now it's going to be a lot heavier, and we're going to be shorter and stronger or something like that, or we'll have gone somewhere else. Who knows? But anyways, that is his book. I apologize. I know it's sort of moving around. I may have missed a few things, like I missed the famous graph of the seafloor beds, but look it up, NOAA. The seafloor bed ages. You can take a look at that, but I figure most people who do know expansion technology know this. I was really trying to give you a big overview survey of this book the best I can in a short amount of time. I've had this book for over a month now, so I'm really pleased to have done that. And of course, I want to thank my friend here, and I want to raise a glass to him. This was us in 2017 at the CMPS conference at Vancouver. We actually had a sponsor bring him to the event so he could get a Lifetime Achievement Award. But this, here's a toast to you, Dr. James Maxlow. It's sort of emotional to me. I don't want to get emotional about it, but your work is absolutely amazing. To me, you're going to be one of the, if not the greatest geologists of all time, at least until someone else comes up with something bigger. But this book is the most important book in geology ever written. I will stand by that fact. I think James himself knows that. He also knows that he is standing on the shoulders of great people, but it took somebody like him to take decades worth of time and the gumption to go against plate tectonics and all the crap, excuse my language, you have to face when you are coming up with a new paradigm and this new paradigm shift. This is plate tectonics today. It is no longer and should no longer be, I agree completely with James, it is no longer expansion tectonics. There's plate tectonics, and the Earth radius is not fixed. It is increasing. That's just part of the game that plate tectonicists have to deal with. So let's deal with it. Let's get this book out there. Let's start using this book to teach the new generation. There's so many dissertations and so much incredibly interesting work that this is going to generate in all the geosciences and in physics, that this is one of the seminal science books of all time. Congratulations, Dr. James Maxlow. I really understand why you did not include expansion tectonics. It took me a month to understand that, but I do understand it now. I tip my hat off to you. Everybody, next time they're out at a bar or someplace and that got their beer or whatever you drink, your smoothie or whatever it is, tip it and give a toast to Dr. James Maxwell for being the first true geologist, has taken the growing and increasing radius of the Earth to the first teachable book on plate tectonics for the next hundreds of years. I'm Dave the Hilster. Remember, I always say, stay critical, stay thinking. I'm your science therapist, trying to get you the promised land, or you're already there, or even get you more science woke. Ciao for now.